Hello everyone, I am Praveen Sharma, Physics Mentor. Welcome back to the NEET Physics Crash Course 2026. Dear students, in this lecture we will cover the chapter Motion in Straight Line. So, first question, pause the video, read the question carefully, and then have a look at the solution, isn't it? So, the condition given the question is that there are two cities, namely X and Y. X and Y, and these two cities are connected by regular bus service. And it is given in the question that every second bus leaves the city X after T minutes, the first one has left, isn't it? Whether the bus is moving from city X to city Y or the city Y to city X, the second bus leaves after every T minute. The first bus is already left. It means that if the first bus has leaves the city X at time t is equal to 0, then after time capital T minutes, the second bus leaves the city X. Then again after time capital T minutes, the third bus leaves the city X. And same is the case with city Y, isn't it? So what happens by the time the second bus left the city X or the second bus left the city Y, the first bus had already covered some distance, isn't it? And that some distance covered by the first bus must be given by the speed of the bus multiplied by the time, because distance is equal to speed into time. So assuming it is given in the question that the speed of the bus, you have to assume it as constant. So the distance covered by the bus in t minutes must be given by Vb multiplied by t, isn't it? So this is the very first conclusion, that the distance between any two successive or consecutive bus is given by Vb into t. So this must be very clear to you, because when second bus left, the first bus had already covered the distance, some distance, and that some distance is given by the speed of the bus multiplied by the time for which it is in motion, isn't it? So it is Vb multiplied by time. Now no matter whether the bus is leaving from X to Y or bus is leaving from Y to X, the distance between any two successive bus is given by Vb into t for the buses moving in X to Y, and for the buses moving from Y to X, again the distance between any two consecutive bus is given by Vb into t. Now the situation is given in the question like, suppose I am riding a scooty and moving from city X to city Y. I observe that after every 30 minutes, one bus overtakes me, isn't it? So the situation, you can express this situation as, suppose here it is scooty and here it is bus. Here it is bus. So bus is moving with a speed Vb, scooty is moving with a speed 60 km per hour, isn't it? Let us suppose there is another bus here. There is another bus here, and at time t is equal to 0, this bus A just overtakes the scooty S. At time t is equal to 0, the bus A just overtakes the scooty S, isn't it? And it is given in the question that the bus behind this bus B, let us suppose this is bus B. So this is bus behind bus A. So it will overtake after 30 minutes, because it is given that after every 30 minutes, the buses overtake the scooty S, isn't it? So if this bus overtakes this at time t is equal to 0, then the bus behind bus A is bus B. So it must overtake the scooty S after 30 minutes, isn't it? So it is given. And the distance between these two buses is given by Vb into t. It means that distance between this bus B and scooty is given by Vb into t, because at time t is equal to 0, both bus A and scooty S are at the same position. So here bus V is approaching towards scooty with speed VB. Here the scooty S is moving along the same direction with speed 60 km per hour, and the distance between the two is VB multiplied by T. So the equation must be like the relative velocity of approach of bus with respect to scooty is given by VB minus 60. So this is relative velocity of approach of bus B relative to scooty S. So this speed must be multiplied by time, after which this bus reaches the position S or overtakes the scooty S. So this is given as 30 minutes. So converting it into hours, so this will be 30 by 60 is equal to the distance between the two is VB into T. So this is the approach of relative velocity where the two objects are moving along the same direction. So this is gets cancelled. So this is 3 ones are, this is 3 twos are. So this will be VB minus 60 is equal to 2 times VB into T. So this is equation number 1. And in the second situation, it is given that I am driving a scooty and I observe that I am moving from X to Y, city X to Y, and the buses are coming from city Y to city X. So after every 10 minutes, one bus crosses me, isn't it? So it is like, let us suppose this is scooty, and this is bus A. At time t is equal to 0, bus is moving from Y to X, that is from right to left. Here it is Y somewhere, here it is X. But the scooty is moving from X to Y, that is moving towards right with a speed 60 km per hour. So here it is bus A and here it is bus B. And the distance between two buses, or the you can say the distance between this scooty and the bus, is given by VB multiplied by T. As we have already found this value, the distance between any successive bus must be VB multiplied by T. So what happens here? Suppose at time t is equal to 0, this bus A just crosses the scooty S at time t is equal to 0. Then after 10 minutes, this bus B will cross the scooty S. This is again the concept of relative velocity here, because the two objects are approaching each other with some speed. So the relative velocity of approach must be given by VB plus 60. 60, that is the speed of scooty, VB, that is the speed of bus with which it is approaching towards the scooty. So relative velocity of approach of bus B towards scooty is given by VB plus 60, because the two objects are moving opposite to each other, and the time after which they meet or they cross each other is given by 10 minutes. So this will be 10 by 60, and this must be equal to the distance between the two, that is VB multiplied by T. So this is 1 by 6. So this expression will be VB plus 60 is equal to 6 times VB into T. So this is the expression. So this is equation 2 and this is equation 1. So as you can see that here it is 1 times VB, here again it is 1 time VB. So if I subtract equation 1 from equation 2, then we have VB gets cancelled. 60 minus of minus 60 is 120. 6 VBT minus 2 VBT is 4 VBT. From here we have value VB is equal to 120 by 4T, that is given by 30 by T. So if I substitute this value of VB in equation 1, then I get VB minus 60 is equal to 2 times, instead of VB write 30 by T into T. T gets cancelled and we have VB is equal to 120 kilometer per hour. So this is the first part of the answer, that VB is equal to 120 kilometer per hour. And as we have the relation that VB is equal to 30 by T, implies that T is equal to 30 by VB. So this is 30 by 120, isn't it? And this will be in hour, because we have speeds here in hours. So this time must be in hour. So this is 1 by 4 hour. So converting into minutes, so this will be 1 by 4 multiplied by 60 minutes. So this is 15 minutes, isn't it? So the answer is speed is given by 120 kilometer per hour, and the time is given by 15 minutes. So option 1, 15 minute and 120 kilometer per hour, isn't it? So next question. So actually this question is given in NCERT. If not in the latest one, then in earlier NCERT, old NCERT, you will get this question. So next question is, the velocity time plot of the motion of a body is shown below, and we have to find its acceleration time graph. So dear students, the very important concept here is, as we know that A is equal to, that is acceleration is equal to dv by dt. And as we have learned in basic maths differentiation lecture, where we have covered the topic differentiation, this dv by dt is nothing but slope of velocity, sorry, slope of velocity time curve, isn't it? And one more thing we have learned, that this slope is given by tan theta, and the slope is constant for instant straight line. Slope is constant for straight line, because for straight line theta is everywhere same, so the slope will be same, isn't it? So observe this carefully. Suppose I name this region as, this is region O, this is A, B and C. From O to A, I am writing here, from O to A, the slope is constant because this is a straight line. Since this is velocity and this is time, so the slope of velocity time curve is constant. It means that in this region, slope is equal to constant. It means that acceleration is again constant, because slope of velocity time curve is given by acceleration. Now from region A to B, velocity is, you can see that velocity is constant. Velocity is constant means acceleration is 0. From region B to C, here the velocity is changing, or you can see it is the case of downfall. So here the slope is negative. Slope is negative. So, and two concepts are being used here. Here the slope is negative because there is a downfall, and simultaneously it is being represented by straight line, so the slope must be constant. So here the slope is negative constant. It means that acceleration is also negative constant. So out of these four graphs, we have to observe that for region O to B, now observe, for region O to A, so this is observe this second graph, this is O A. So for region O to A, slope is positive constant, acceleration is equal to constant. So here we have acceleration as constant. So this is O and this is A. Acceleration is constant here, isn't it? After that, what happens? The acceleration is 0. So here it is graph from O to A here. Then from A to B, the acceleration is 0, this value. And again from after that, the slope is negative constant. So this is negative constant, isn't it? Because the slope is not changing within this time interval, it is having negative value but constant. So option B is the correct answer. And rest of the options are, as you can see, this is 100% false, isn't it? So in this way, you have to convert the given graph into the acceleration time graph. Now particle shows distance time curve given in the figure, the maximum instantaneous velocity. Again the same concept. If you talk about velocity, isn't it, and for uniform, for unidirectional motion, that is moving along a straight line, the distance and displacement becomes same and the position becomes same. So this v is given by dx by dt, isn't it? And this dx by dt is nothing but slope of distance time graph or position time graph. So this is velocity. So what happens? The maximum instantaneous velocity, we have to find maximum instantaneous velocity. So the velocity will be maximum where the slope is maximum. So out of the region A, B, C and D, observe carefully, the slope is maximum at, here it is somewhere x, here it is So you can find this value as, you have to find theta. So here it is theta, here it is theta, here it is theta, and here. So you can easily understand that the value of theta is maximum at point C. It means that tan theta is maximum at point C, and tan theta is nothing but slope of this curve. So slope is maximum at point C, therefore velocity is maximum at point C, isn't it? Now some students may ask, sir, velocity is given by a rate of change of position, that is dx by dt, but here in the question it is given as distance. So remember, dear students, whenever it is not given, so consider the given motion as unidirectional motion as far as NEET is concerned. And for unidirectional motion, if you take the start point as origin, then the three quantities are interchangeable. That is, distance is equal to position is equal to displacement, isn't it? So whether in the y-axis, if you put displacement, if you put distance, and if you put position, its slope is given by the velocity. That's all, isn't it? So option C. Next. A particle moves along a straight line OX at a time t. The distance x of the particle is given by x is equal to 40 plus 12t. How long would the particle travel before coming to rest? So how long will the particle travel before coming to rest? It means that when it comes to rest, it may, at that time the velocity of the particle is 0. So first of all, we need to find the time after which the velocity of the particle becomes 0, and then we will find within that time interval the distance covered by the object, isn't it? So first of all, we have to find velocity, which is given by dx by dt. So differentiate this expression, you will get 12 minus 3t square. Now we have to find the time at which velocity becomes 0. So we put v is equal to 0. So this will be 12 minus 3t square is equal to 0. It means that 3t square is equal to 12. So t is equal to 2 seconds. It means that velocity becomes 0, or the object comes to rest at time t is equal to 2 seconds. So we have to find the distance of the particle within this time interval 2 seconds. So what we do, we just put t is equal to 2 in the given expression, 12t minus 2 cube. So this will be given by 40 plus 12 into 2 minus 8. So this will be 40 plus 24. This is 40 plus 16, and this is 56 meters. So this is the answer, isn't it? So that's all. Next. The displacement x of a particle varies with time. So this is the expression given for displacement, isn't it? Where alpha, beta, all these values are positive constant. The velocity of the particle will be, now we have four options. So it is better if you find the expression for velocity. As you all know, v is given by dx by dt. So I am writing the expression for d here. So v is equal to d by dt of, so the first term is a e to the power minus alpha t, a to the power minus alpha t, plus second term d by dt of b e to the power beta t. Now you can differentiate this. So a is constant, take it outside. The differentiation of e to the power x is e to the power x. So here it is e to the power minus alpha t. Then according to chain rule, when you differentiate this alpha t, then this will be minus alpha t. Similarly here, take b outside as it is constant. So differentiation of e to the power beta is same, e to the power beta. Then you have to differentiate beta t. So this will be beta, isn't it? So v is given by here minus alpha a t e to the power minus alpha t, plus this is beta b e to the power beta t, isn't it? And here one more thing, you are observing this t should not come, because alpha t, when you differentiate alpha t, you will remain with alpha, isn't it? So this t will not come. So the expression is like this one. So let's see. So be independent of beta. This option cannot be because here the beta comes. Drop to 0 when alpha is equal to beta. Again, this is not possible because a and b are different constants. So this is not possible. Go on decreasing with time, go on increasing with time. So this we have to find whether it is increasing with time or whether it is decreasing with time, isn't it? So let us observe it here. This is beta b e to the power beta t minus, here it is a alpha by e to the power alpha t. So what happens as time increases, this value gets increased by this value increases, and as time increases this value decreases. So their difference must increase, isn't it? If time increases, their difference must increase because the first term will increasing but the second term decreases when time decreases, because here e to the power alpha t is in denominator, so the difference must increase, so we have more value. So the option go on increasing with time must be correct, isn't it? Now if time becomes less, so this value becomes less and this value becomes more. So what happens, it is like the difference becomes less because the first term value of the first term getting increased decreasing by some amount, and the value of the second term increases by some amount. So the difference between the two, which is given by velocity, must become lesser, isn't it? So the last option must be right, that if time increases then this term increases, value of this term increases and the value of second term decreases, so the difference between the two must increase, isn't it? So it is velocity go on increasing with time. So next question, the displacement time graph of moving particle is shown below. The instantaneous velocity of the particle is negative. See, again velocity is given by slope of displacement time curve. So positive slope means rising, negative slope means downfall. So out of C, D, E and F, C is rising, D is rising, but when you are at point E, you are actually not rising, you are moving downwards. So here at point E, here it is negative slope, it means that velocity is negative. So the instantaneous velocity of particle is negative at point E, isn't it? Next, which of the following curves does not represent motion in one dimension? So dear students, if you observe, at every instant of time the velocity of the particle is different, so this can happen here also, this can happen, this is possible, this is possible, this is possible, sinusoidal oscillatory kind of motion. But here if you observe, at a particular time the object is showing two different velocities, which is not possible, isn't it? Does not represent, so this is our option because it is not representing one dimensional motion. Next, a particle is moving along x-axis with its position x. It is given. The ratio of its initial velocity to its initial acceleration r. So it is given x is equal to alpha t to the power 4 plus beta t square plus gamma t plus delta. The ratio of its initial velocity to its initial acceleration. Now, whenever we say initial velocity or initial acceleration, anything initial, it means that at that time we have to take the time t is equal to 0. For example, if someone asks what is the initial position of the particle, then we put t is equal to 0 in the given expression. Then we get x is equal to delta, that is the initial position of the particle. Similarly, if I asked you to find initial velocity, then first I have to find the expression of velocity, and in that expression we put t is equal to 0 for initial velocity. So this will become, we have to differentiate this, so this will be 4 alpha t cube plus 2 beta t plus gamma plus this is 0, differentiation of delta is 0. So initial velocity is given by, so at t is equal to 0, v, that is initial, is given by This is 0 0 and this is equal to gamma. So this is initial velocity. Put t is equal to 0 in the expression of velocity, you get initial velocity. Similarly, to find acceleration, we have to differentiate velocity, and that will be 4 3s are 12 alpha t square plus 2 beta plus 2 beta. Now again acceleration depends on time. So if we are asked to find initial acceleration, then what we do? We put t is equal to 0 here. So this will be 2 beta. Now the ratio of initial velocity to initial acceleration is gamma is to 2 beta. So option D is the correct answer, isn't it? Next, a particle of unit mass, that is 1 kg mass, undergoes one dimensional motion such that velocity is given in this way. The acceleration of the particle as a function of x is given by. So we have to find acceleration, isn't it? So acceleration is given by dv by dt. So here a is equal to d by dt of, and since v is given as beta x to the power minus 2n. So here observe the chain rule which we have learned in the lecture differentiation under the topic basic maths. It is very important. So first to go through that if you have not visited there. So as you can see here, the function is in x, but we have to differentiate this function with respect to t. So what happens? Beta is constant, take it outside. Here x to the power, so this is minus 2n, x to the power minus 2n minus 1. Since the differentiation of x to the power n is nx to the power n minus 1. And then finally put here dx by dt. Why we have to put dx by dt? Because the function is in x and we have to differentiate it with respect to t. So this is the way we differentiate such kinds of expressions, isn't it? If it is not clear to you, then please visit or go through the lecture of differentiation in the basic maths. You get that lecture in the playlist of this channel, that is NEET Crash Course 2026, isn't it? So this is minus 2n beta x to the power minus 2n minus 1, and this dx by dt is nothing but velocity, and velocity is given by beta x to the power minus 2n, x to the power minus 2n. Now we have acceleration is equal to 2n minus 2n. This is beta square, and this is x to the power minus 2n minus 1 minus 2n. So this will be 2n beta square. So this is x to the power minus 4n minus 1. So this is the expression, isn't it? So here we have minus minus. So minus 2n beta square x to the power minus 4n minus 1. Just follow the rules, you will get the same answer, isn't it? Next question. A particle moving along x-axis has acceleration f at time t given by f is equal to. So here f is equal to, if I open the bracket, so this will be minus f naught t by t, where f naught and t are constant. The particle at t is equal to 0 has 0 velocity. It is very important information. At time t is equal to 0, velocity is 0. In the time interval between t is equal to 0 and the instant when f is equal to 0, the particle's velocity is. Now this is important, isn't it? So the time given is in between time t is equal to 0 and the instant when f is equal to 0. So first we have to find that instant where f is equal to 0. So what I do, we put f is equal to 0 is equal to f naught minus f naught t by t. So what happens here, this f naught t by t is equal to f naught. This gets cancelled and this t is equal to t. It means that at time t is equal to capital T, the acceleration becomes 0. And at this time we have to find the velocity of the particle. So since as we know that dv, or you can write a is equal to dv by dt. So from here we have dv is equal to a dt. This is acceleration and this is how we write this. So this is infinitesimal small change in velocity given by acceleration multiplied by small infinitesimal small time interval. So here if I integrate this, we will get the velocity, isn't it? So first of all, here it is dv, and instead of a, I must write the expression given, that is f naught minus f naught t by t. F naught minus f naught t by t. So we have to integrate this. Now, apply the limits carefully. What happens? It is given that in the time interval between t is equal to 0. So here the limit is from t is equal to 0 to the instant when acceleration becomes 0. So acceleration becomes 0 at time t. Here we have found out that value. So here it is time t. Now we have to apply the corresponding limits in velocity. So when time t is equal to 0, velocity is 0. Here it is given in the question, at time t is equal to 0, velocity is 0. So put here velocity is 0. And at time capital T, the velocity we have to find. Let us suppose that is v. So we have to, so integration of dv is v. So this is lower limit 0, upper limit is v. So on differentiating this, we will get f naught t from 0 to t, minus this is f naught by t, this is t square by 2, 0 to t. Integration of t is t square by 2. So this is v minus 0, and this is f naught t minus 0 minus f naught by t, and take 2 outside. Here it is t square minus 0. So here you will get v is equal to f naught t minus f naught by 2t into t square. So one t gets cancelled, and this is given by f naught t minus f naught t by 2, that is f naught t by 2. So this is the expression, that is f naught t by 2. So the question is option C is the correct. Next, the position of a particle varies with time t. It is given the acceleration of the particle will be 0 at time t equals to. So we have to find the time at which acceleration is 0. So first we need to find the expression of acceleration, and then we put that expression equal to 0. So v is equal to, first of all, to find acceleration we must find the expression for velocity, and that will be given by 280 minus 3bt square. Implies that acceleration is given by dv by dt, that we have to differentiate this expression of velocity. So this will be 2a minus 6bt, isn't it? So we have to find the time at which acceleration becomes 0. So this is the expression of acceleration. To put acceleration is equal to 0, so this is 2a minus 6bt is equal to 0, implies that 6bt is equal to 2a, so 2 ones are 2 threes are, and t is equal to a by 3b. So at time t is equal to a by 3b, the acceleration gets 0. So this is option B, time a is equal to 3 by b, isn't it? Next, given that a car accelerates from rest at a constant rate alpha, and then after that it decelerates, and finally it comes to rest. So car is starting from rest, and finally it again achieves the velocity rest. So total time for which it is in journey is given as small t, isn't it? So we have to find the maximum velocity during the journey. So it is very common sense that until and the acceleration is there, the velocity of the particle keeps increasing, isn't it? Whenever the car starts decelerating, the velocity gets decreasing. So its velocity is maximum until there is acceleration, isn't it? Let us suppose I am assuming that car is accelerated from during until time t is equal to t dash. So this is the time interval for which car is being accelerated, and after t dash car speeds keeps on decreasing because of deceleration, but till time t dash the velocity of car keeps increasing because of acceleration. That's all. So at the time t dash the car's velocity will be maximum, because until time till time t dash there is acceleration. After that the deceleration starts, that velocity gets decreasing, isn't it? So what is given, let us suppose I am taking the maximum velocity achieved by the car is v. So during acceleration, the car starts from rest. So its initial velocity is 0. So applying the first equation of motion, we have 0 plus alpha into t dash. T dash is the time of during which the car is being accelerated. So v is given by alpha into t dash. Now we have to find the expression for maximum velocity, and for maximum velocity we have to find the value of t dash. Now dear student, the total journey time of car is t. The first half of the journey is being the case of acceleration, we taken that time interval to be t dash. So the during deceleration time is given by total journey time minus time interval for which it is an acceleration. So this is deceleration time is given by t minus t dash, where t is the total time of journey and t dash is the time for which the car is being in acceleration. So here we are writing deceleration time. Now during deceleration, what happens? During deceleration, what happens? The car's initial velocity is considered as v. Why? Because during acceleration the car velocity keeps on increasing and increases till this point. So during the journey of acceleration, the velocity at this point is final velocity of the car. But what happens after this point? Deceleration starts, the velocity keeps on decreasing. So during the journey of deceleration, this velocity is the initial velocity and finally car comes to rest. So during deceleration, the initial velocity is v and the final velocity is 0. So applying the first equation of motion, this final velocity is equal to initial velocity plus, since there is deceleration, in such cases we take minus of b, isn't it? Because the rate is given as beta, and multiplied by t minus t dash. T minus t dash is the time interval for which the car is in deceleration. So this will be 0 is equal to v minus beta t plus beta t dash. So from here we can find beta t dash as beta t minus v. So t dash is equal to, since this is beta, beta gets cancelled, t minus v by beta. So substituting the value of t dash in this expression, we get v is equal to alpha t minus v by beta. Opening the bracket, we have this is alpha t minus alpha v by beta. Taking left side, we have v plus alpha v by beta is equal to alpha t, implies that v 1 plus alpha by beta is equal to alpha t. So right side, so this will be, first of all, this will be beta plus alpha by beta is equal to alpha t, and finally we get the value, this is alpha beta t by alpha plus beta. So this is the expression for maximum velocity, isn't it? You can take its screenshot if you want. So the expression option is option D. Next, a horizontal bridge is built across a river. A student is standing on the bridge throws a ball vertically upwards with a velocity 4 meters per second. The ball strikes the water surface after 4 seconds. The height of the bridge above the water surface is. So the question is like this. The situation is, let us suppose here it is water, here it is water, here it is surface of water, and here it is bridge. Here we have the bridge like this. Let us suppose the height between this bridge and the surface of water is h. Now what happens? One ball is being thrown from this bridge with velocity 4 meter per second. So this is 4 meter per second. So the journey of the ball would be like, first ball reaches the point. Suppose the ball starts its journey from point O, reaches the highest point A, then again comes to point O, and finally it reaches the river surface, that is R. So we have to find the value of h. Here we need to find h is equal to question mark, isn't it? So how can you solve this question? So the ball strikes the water surface after 4 seconds. The question what is given, that the time, since the ball first starts its journey from O, then it reaches point A, then again O, and finally reaches the river surface, isn't it? So O to A to R. So let us suppose the time given for this journey, I am taking it as t and it is given in the question as 4 seconds. We have to find the height, isn't it? So you can directly apply, since whatever we have learned the equations of motion, these equations of motion, we have acceleration, initial velocity, final velocity, time, and we have s. The s used in these equations of motion is representing the displacement, isn't it? And what is displacement? Displacement is final position minus initial position. So instead of taking two different equations of motion, that is from O to A then A to R, I am taking the journey, this one, that is from O to R. Initial position, this is initial position IP, and R is the final position FP. Now, so applying the concepts carefully, isn't it? This is initial position, this is final position. So what is the direction of displacement? This is initial position, this is final position. So direction of displacement is always from initial to final. So the direction of displacement is downward, isn't it? And the direction of velocity, initial velocity is upward, and the direction of acceleration, that is acceleration due to gravity in such free fall cases, is always downward. So in such kinds of questions now, physics gives us freedom. We can choose any direction as positive, and opposite to that direction the other will become negative. For example, in this question, suppose if I take the downward direction as positive, so what happens? The upward direction becomes negative. Yes, physics gives us the freedom. So here the h, since it is from O to R, vertically downward direction, we take it as positive. Acceleration, O to R, again downward direction, we take it as positive. But the direction of initial velocity, since the ball is thrown vertically upward, so it must be negative. So using the second equation of motion, that is s is equal to ut plus half at square, we have h, I am putting it plus h because downward direction we have taken as positive. U, since the direction of u is vertically upward, so we will take u as minus. So u is given as 4 meter per second, so we consider it here as minus 4, and the time is 4 seconds, plus half. G is given as 10 meters, so this is 10, and the time is 4 square. So we get, this is minus 16 plus 2 ones are 2 5s are 5 into 16 80. So this is 80 minus 16, that is 64 meter. This is the answer. Next, the ratio of the distances traveled by free falling body in the first second, third and fourth second is, in the first second. So in the first second, let's suppose I am writing S1, it is given by u is 0, no? In the case of free fall, u is 0, isn't it? So u plus ut plus half at square, so the expression will be like half, and instead of a we write g because we have to find the ratio, and t square is 1 square, so this will be g by 2. Now during second, so as we all know that distance traveled by nth second is given by u plus a by 2, 2n minus 1. So directly applying this formula, we have as nth, yani as second, so we have 0 plus g by 2. So here it is 2 into 2 minus 1. So here it is g by 2 into 3. Similarly, as displacement in third second, so this is u plus a by 2, that is g by 2. 2n minus 1, that is 2 3 is 6 minus 1 is 5. So observe the pattern. As first is to as second is to as third is to as fourth. So this is g by 2 multiplied by 1. This is g by 2 multiplied by 3. This is g by 2 multiplied by 5, and this is g by 2 multiplied by 7. Isn't it? Observe this pattern. 3 to the 6 minus 1, 2 to the 4 minus 1. Similarly, 4 to the 8 minus 1, 7. So this g by 2, g by 2, g by 2 gets cancelled, and finally we will get 1 is to 3 is to 5 is to 7 is to 9. So this is the answer. Next. A stone falls freely under gravity. It covers distance h1, h2 and h3 in the first 5 seconds, the next 5 seconds and the next 5 seconds. So let us first find the expression for h1. So this is given by, since it falls freely, so initial velocity is 0. So this will be half g into 5 square. So this will be 25 g by 2. So this will be 25 g by 2. Now, in the next 5 seconds, first of all, the h1 is the distance it covers in the first 5 seconds. Then in the upcoming 5 seconds, it covers distance h2. So what is h2? The distance covered in first 10 seconds minus the distance covered in first 5 seconds. So what is h2? That is distance covered in first 10 seconds minus distance covered in first 5 seconds, and that is given by h1. So here it is half g 10 square minus 25 g by 2. So here it is again g by 2, 100 g by 2, 100 g by 2 minus 25 g by 2. So this is 75 g by 2. So this is h2. Similarly, the distance covered in the next 5 seconds, first 5 seconds, second 5 seconds, and the next, that is third 5 seconds. So the distance covered in third 5 seconds is given by distance covered in first 15 seconds minus distance covered in first 10 seconds. So this will give the distance covered in third 5 seconds, isn't it? So there are 3 slots now. First 5 second distance covered is h1. In the second, next 5 second, the distance covered is h2, and then again next 5 second, the distance covered is h3. So if you combine all these, h1 plus h2 plus h3, you will get distance covered in the first 15 seconds. And if you subtract the distance covered in first 10 seconds from the distance covered in first 15 seconds, then you will get the value of distance covered in third 5 seconds, that is h3. So h3 is distance covered in first 15 seconds minus distance covered in first 10 seconds. So this will be given by, again this is ut plus half at square. So this is half g 15 square minus half g 10 square. So this will be 225 g by 2 minus 100 g by 2. So this is 125 g by 2. So the ratio is h1 is to h2 is to h3 is given by h1 is 25 g by 2 is to h2 is 75 g by 2 is to, this is 125 g by 2. G by 2, g by 2, g by 2 cancel. 25 1s are 3s are 5s are. So here we have h1 is to h2 is to h3 is 1 is to 3 is to 5. So we can have, listen, h1 is equal to h2 by 3. From here we have h1 is to h2 is equal to 1 is to 3. Implies that h1 is equal to h2 by 3, isn't it? Similarly, what happens here, we have h1 is to h3 is equal to 1 is to 5. So here we have h1 is equal to h3 by 5. So the option comes is h1 is equal to h2 by 3 is equal to h3 by 5. So option B is the correct answer. Option B. Next. In the question it is given that a ball is being dropped at t is equal to 0, isn't it? And let us suppose at t is equal to 18 seconds, it reaches the position A. So this is the case of ball 1, which I have drawn by using blue marker. Now what is given that at t is equal to 6 seconds, another ball is being thrown with velocity v from the same height and it reaches the same position A after 12 seconds, isn't it? Because it is given in the question that the two balls meet at time t is equal to 18 seconds. So by the time second ball is thrown, the first ball has already covered the distance for the time interval 6 seconds, because there is a difference in their journey time, isn't it? The second ball, that is the black one, starts its journey after 6 seconds. So what happens? Actually, the time of journey for ball 1 is 18 seconds, but the time of journey for ball 2 is 18 minus 6, that is 12 seconds, because it has started its journey from time t is equal to 6 seconds and it reaches the position A at time t is equal to 18 seconds. So from 6 seconds to 18 seconds, its journey time is 12 seconds. So we have to time its velocity. So are you getting now? One ball is being dropped at t is equal to 0, and after 6 seconds, tick tick, 1 2 3 4 5 6, second ball is thrown, and we observe that the two balls meet, or two balls at the same position at time t is equal to 18 seconds. So if I write, so the height must be same in the two cases. So for ball 1, if I write for ball 1 h, if I wish to find, so this will be, since initial velocity is 0 because it is being dropped, so this will be ut plus half gt square. So this is half g and t is 18 square. So we have to take g as 10. So this is 5 into 18 square. Equation number 1. Now for ball 2, h is given by ut plus half at square. So this will be v, and here t is nothing but 12 seconds. The journey of motion, time of journey is 12 plus g by 2 into 12 square. So this will be 12v plus 5 into 12 into 12. This is equation number 2. Since h is same in both the cases, so we can equate the right hand side of the above equation. So we have 12v plus 5 into 12 square is equal to 5 into 18 square. So 12v is equal to 5 18 square minus 12 square. Take this right side. So you will get 12v is equal to 5. This is a square minus b square. So 18 minus 12, 18 plus 12. So this will be 5, 18 minus 12 is 6, 18 plus 12 is 30. So this will be 6 ones are, 6 twos are, 2 ones are, 2 15s are. So v is equal to 15 fives are 75 meter per second. So this is the answer, isn't it? 75 meter per second, option A. You can take a screenshot if you wish. This is the answer. Now next, a particle starts its motion from rest under the action of a constant force. Since the force is constant, it means that acceleration is constant. And if acceleration is constant, then you can use the three equations of motion. If the distance covered in first 10 seconds is s1 and that covered in first 20 seconds is s2, then so s1 is given by, since the particle starts from rest, so initial velocity is 0. So using second equation of motion, ut plus half at square, so u is 0, so no need to write the first term. So this will be a t square by 2. So in the first second, a tan square by 2, so this is 50a. Similarly, if you find a displacement in the first 20 seconds, then this will be a by 2 20 square. So this will be 400 by 2, that is 200a, isn't it? Distance covered in first and that covered in first 20 seconds in s2. So this is the distance covered in first 20 seconds. So this will be 400a by 2, that is 200a. So here we have s2 is equal to 4 times s1, that is c, isn't it? Because you multiply 4 into 50 is 200a, that is s2. So this is the answer. The distance traveled by particle is starting from rest and moving with a uniform acceleration is 4 by 3 meter per second in the third second is. So the formula for nth second is given by, this is the formula, as nth is equal to u plus a by 2, 2n minus 1. So if you wish to find the distance in the third second, so this will be u plus a by 2. This is 2n minus 1. 2 3 is 6 minus 1 is 5. So here the particle is starting from rest. So u is 0. moving with acceleration 4 by 3, and here it is 2, and here it is 5. So this will be 20 by 6, that is 10 by 3, option C. Next, two particles move with initial speeds of 4 meter per second, and their accelerations are given. If both reach at final position in the same time, then the length of path traveled is, isn't it? Both reach the final position at the same time. So in the two cases, T1 is equal to T2 is equal to T, say ऐसा हमने ले लिया. So the first particle is having initial speed. Let us consider the first particle. So first particle, if I wish, so u1 is 4 meter per second, isn't it? Acceleration a1 is 1 meter per second square. So the distance covered by the first particle is given by u1 t1 plus half a1 t1 square. So this is s1 is equal to u1 is 4, t1 t2 same 4t plus this is 1 by 2, and acceleration is 1, and this is t square. So this will be s1 is equal to 4t plus t square by 2. Now s2, what is s2? That is distance covered by the second particle in the same time interval. So this will be s2 is equal to again u2t plus half a2 t2 square, and since t2 and t1 are equal to t, so this will be again u2. So u2 here it is given as 2 meter per second, and acceleration is 2 meter per second square. So this is 2t plus 2t square. So this will be 2t plus t square. Since it is not given whether the particle follows the same path or different path, but always remember in such question where there is a confusion, I have said you earlier that consider it as unidirectional motion, that the direction of motion of the two particles is same. So the displacement of the two must be same, because for linear direction the distance and displacement becomes equal. So s1 is equal to 4t plus t square by 2, s2 is equal to 2t plus t square by 2. So move with they reach the same final position in same time. It means that the distance covered by the two must be same. So this will be 4t plus t square by 2 is equal to 2t plus t square by 2. So this will be 2t is equal to t square by 2. So one t gets cancelled, and from here we have t is equal to 4 second. So this is the answer. So I mean this is the time t. So from here we can find the value of, whether you can find the value of s1 or you can find the value of s2. Both will be same. So put t is equal to 4 here. So this is 4 into 4 plus 4 square by 2. So this will be 16 plus 8, that is 24 meter. And from here you can also find 2 4s are 8, and this is 4 square, 16 plus 8 24. So the answer is 24 meter, isn't it? So this is a logic. Next is ball is thrown vertically with the speed u. So the situation is, let us suppose this is a ball is being thrown vertically upward with a speed u, and the highest point where the velocity becomes 0, isn't it, is point A. Then we are asked to find the distance covered by this ball during the last t seconds of its ascent, isn't it? So always remember, suppose I ask you what is the distance covered by the ball during its upward journey in the last 2 seconds of its journey. So it will be equal to the distance covered by the ball when it falls freely during the first 2 seconds of its journey, isn't it? For example, if you drop a ball from this point D, drop a ball means initial velocity is 0. So suppose in the first 2 seconds it covers the distance y, isn't it? So during its motion, in the case of free fall, it covers the distance y in the first 2 seconds, isn't it? So it will cover the same distance when the ball goes vertically upward, that is, it covers the same distance y in the last 2 seconds of its ascent. Suppose you are asked to find what is the distance covered by this ball which is going vertically upward, I mean which is being thrown from the ground vertically upward. So you are asked to find the distance covered by the ball in the last 3 seconds of its ascent, or you can say in the last 3 seconds of its upward journey. So it must be equal to the distance covered by the ball during free fall in the first 3 seconds of its journey, isn't it? So in this question you are asked to find the distance covered in the last t seconds of its ascent. So it will be equal to the distance covered by the free fall ball during the first t seconds. So during the first t second, the distance given by this is ut plus half at squared. So in the case of free fall, this u becomes 0, isn't it? So this will be half, or g is here is a t, and this is t squared. So this is the answer. So this is the logic concept. You can prove this. A man throws ball with the same speed vertically upwards, one after the other, at an interval of 2 seconds, isn't it? So suppose here it is a ground, and here it is a man throwing a ball one after the other. So let us suppose the first ball is being thrown at t is equal to 0. So what happens at t is equal to 2 seconds? It will throw second ball. It means that a man throws ball with the same speed, and let us suppose the speed is given as u, one after the other at an interval of 2 seconds. It means that first ball he throws up at t is equal to 0, then at t is equal to 2 seconds he throws second ball, then at t is equal to 4 seconds he throws third ball, in this way. So what should be the speed of throw so that more than 2 balls are in the sky at any time? So we have to find the speed u, isn't it? So in the first, let us suppose at t is equal to 0, first ball is being thrown, and in at t is equal to 2 seconds, second ball is being thrown, and the third ball is being thrown at t is equal to 6 seconds. So according to condition given in the question, what is given that at any time there must be 2 balls in the air. So what happens at t is equal to 6 seconds? At t is equal to 0, the first ball is being thrown. At t is equal to 2 seconds, the second ball is being thrown, and at t is equal to 4 seconds, the third ball is being thrown. So the out of the 2 balls which you already thrown at t is equal to 0 and at t is equal to 2 seconds, out of these 2 balls, no ball should reach the ground before the third ball is being thrown, isn't it? Out of those 2 balls which you have thrown at t is equal to 0 and t is equal to 2 seconds, should not reach the ground before the throwing of the third ball. Only then it is possible that at any time there are 2 balls in the air, isn't it? So what happens now? There the 2 balls should be in air at time t is equal to 0 to 2 is equal to 4 seconds, because at time t is equal to 4 seconds the third ball will be thrown. So the velocity of the ball must be or should be such that it will be in air for time period t is equal to 0 to 2 is equal to 4 seconds. So if I talk about first ball which is being thrown at t is equal to 0. So it should be in air for, so this first ball should be in air for t is greater than 0 and less than or equal to 4 seconds. Then what happens if at t is equal to 4 seconds it strikes the ground, then the third ball will be thrown at t is equal to 4 seconds, because at regular intervals of 2 seconds the balls are being thrown, isn't it? So the minimum time must be that for t is equal to 0 to t is equal to 4 seconds. It means that one ball must be in air for this 4 seconds. So what happens now, if this is 4 seconds, then as from our common sense we know that if the ball starts its journey from O on the ground, then and the total journey time, that is from O to A to O, is 4 seconds, then the journey time for O to A is 2 seconds, because half of the time is required to get the maximum height and remaining half will be for the downward journey. So the time of flight is 4 seconds, but the half for reaching the maximum height from the ground is, that will become 2 seconds. So for O to A, the time is 2 seconds. We have to find the U for this 2 seconds, isn't it? So this will be, how can you find this U? So this will be that velocity at maximum height will be 0. Acceleration is, again, you can find acceleration is, that is minus z. So using the first equation of motion, that is v is equal to u plus at, this is 0 is equal to u minus gt, and u is equal to gt, and here u is equal to 2 into g, because t is equal to 2 seconds for this journey O to A, and g, we have to take g, it is not given, so take g as 9.8, so this will be 19.6 meter per second. So it is the minimum required velocity with which the ball must be thrown, so that the two balls in air. If you throw the ball with a speed more than this value, then there will be more than two balls in the air for some time. But if the velocity of throw is less than 19.6 meter per second, then there will be some time when there is only single ball in the air, because before being thrown of the third ball, the second ball reaches the ground. That is before t is equal to 4 seconds. So at least, or you can say more than 19.6 meter per second. Next question. A car moving with a speed of 40 km per hour can be stopped after 2 meters by applying brakes. If the same car is moving with a speed of 80 km, what is the minimum stopping distance? So since the car is same, in such question the brake is being applied, practically the amount of brake will be different. But in such questions, we take the amount of brake force as constant in the two cases. So the acceleration, whether you call it deceleration, is same in the two cases. So from the first case, the car moving, it is initially it is giving at 40 km per hour. So this is 40, convert it into meter per second. So this is 5 by 18. So this is 200 by 18 meter per second. Final velocity is 0, and the distance covered during this deceleration is, or during this brake is 2 meter, isn't it? So acceleration given by is, for using the third equation of motion, that is v square is equal to u square plus 2as, we have a is equal to v square minus u square by 2a. So this is v square minus u, this is 0 minus u square is 200 square by 18 square whole divided by, this will be 2s, this will be 2s, isn't it? So whole divided by, s is given here is 2 meters, so this is whole divided by 4. So acceleration is given by, this is 200 square by 4 into 18 square in minus, because it here it is 0, and this is 2s now. From here we have v square minus u square by 2s, this is not 25, this is 2s. Now if the same car is moving with a speed of 80 km per hour, so case 2, what is given in case 2, that initial speed is 80 km per hour, so this is converted into 80 into 5 by 18, that is meter per second. Again final speed 0, so here we have to find the minimum stopping distance. So s is given by v square minus u square by 2a. So s is equal to v square, that is 0 minus u square is this much value, 85 is a 400 square by 18 square, and this will be divided by 2 into a, and we have value of a as minus 200 square, this is minus 200 square, isn't it, divided by 4 into 18, 4 into 18. So minus is outside the 200, so this will be s is equal to, this is minus 400 into 400 by 18 into 18 into, now this will be 4 into 18 by 200 into 200. So this is the value, and listen, this is 200 square by 18 square now. This is 200 square by 18 square. This is, so this is again, this is 200 square by 18 square. This is like this. This is 18 square. 18 square. So this 18, 18, 18, 18 gets cancelled. This 2 into 200 is 400 cancel. This 0, 0, 0, 0 gets cancelled, and this will be s is equal to, now minus minus becomes plus here, isn't it? So this will be become 4 into 4 16, and 16 by 2, that is 8 meter. So we have the option 8 meter. Here it is 2 is left, 4 into 4, this is 16 by 2 is 8 meter. So you can solve it now. You can solve it. I am giving you the just procedure of solving. So this is how we can do it. So if the ball is thrown vertically upwards with a velocity of 40 meter per second, then the velocity of ball after 2 seconds will be. So this is v is equal to u plus at. So this is 40 plus minus, because acceleration is minus of 10 and t is 20. So this is 20 meter per second. So this is the answer. Next, a body starts from rest. What is the ratio of distance traveled by the body during the fourth and the third second? Since the distance traveled in fourth and the third second, isn't it, as for third? So the formula is u plus a by 2, 2n minus 1. So here u is 0 because the initial velocity is 0 as the body starts from rest. So this is a by 2, 2n minus 1. A by 2, 2n minus 1. Yes. So this is a by 2, 2n minus 1. So here 2n minus 1 is 2 4s are 8 minus 1, that is 7. And here 2 3s are 6 minus 1, that is 5. So we have the relation 7 by 5, option A. Because 4th is to 3rd it is asked. So this is 7 by 5. Next. What will be the ratio of distance moved by freely falling body from rest in 4th and 5 seconds of its journey? Again the same logic, a by 2 cancel. So this is 2 4s are 2n minus 1, 2 4s are 8 minus 1, 7, and 2 5s are 10 minus 1, 9. 7 is to 9. Verbally you can solve such kinds of question. Because we are left with this one, displacement in ns second is u plus a by 2, 2n minus 1. Since the bodies fall freely, na, free falling means initial velocity u is 0. So we are left only with a by 2, 2n minus 1. So in this case both bodies falls freely. A in both the cases is same. So when you find the ratio, this a by 2 gets cancelled and you are left with 2n minus 1. Here n is the 4th second. For 4th second n becomes 4, that is 2 4s are 8 minus 1, 7. For 5th second n becomes 5, that is 2 5s are 10 minus 1, 9. So 7 is to 9 is the answer. Then a car is moving along a straight road with a uniform acceleration. It passes through 2 points P and Q separated by distance with velocity 30 km per hour and 40 km per hour. The velocity of the car midway between P and Q is. So let us suppose here it is point P and here it is point Q. The velocity at point P is, it passes through 2 points separated by distance with velocity. So here the velocity is 30 km per hour, 30 kph, and at point Q velocity is 40 kph, that is 40 km per hour. The velocity of the car between P and Q is, so here the velocity of the car between P and Q. So here let us suppose the midpoint is M. We have to find this velocity, isn't it? So during its entire journey, whether you talk about journey of the car from P to M or for P to Q, in both the cases the acceleration of the car is same, because it is, it is following the same acceleration. It is given in the question, uniform acceleration. So for journey P to Q, first we will find acceleration for journey P to Q. So the distance is given by, let us suppose the distance here is x. It is not given, but we are taking it x. And in the second case, for P to M, let us suppose the distance is, since it is midpoint, so this will be x by 2. So I am taking the journey P to Q. So using the second equation of motion, x is equal to, you can take second or you better take third equation of motion. Third equation of motion. So x is given by v square minus u square by 2a, or you can write acceleration is given by v square minus u square by x, isn't it? So in this case, v is 40 square minus this is 30 square by x. And since this is this is 2a, so this will be 2x, this is 2x. So here we get the expression of acceleration. So let us suppose this is expression 1. Now in the second case, that is for journey P to M, where M is the midpoint of the journey, the initial velocity is 30 and the second velocity, that is velocity of point M, is v. So we can take acceleration as the final velocity is v, that is v square, minus initial is 30 square, and this is 2 into distance. So in this case, distance is x by 2. So this cancel, this is equation 2. So since the two expressions belong to the same quantity, that is acceleration, so you can equate the right hand side of these two equations, that is 40 square minus 30 square, or you can write v square minus 30 square by x is equal to 40 square minus 30 square. So this gets cancelled. So this will be v square is equal to 40 square minus 30 square by 2 plus 30 square plus 30 square. So this will be v square is equal to 40 square minus 30 square plus 2 into 30 square and whole divided by 2. On further solving, you will get this is 40 square is 1600 minus 900 plus 2 into 900 is 1800 divided by 2. So v square is equal to 1600 plus 900, 2500 divided by 2. So this will be v is given by root over 2500 divided by 2. So this is 50 by root 2, or you can write 25 into 2 over root 2. So this will be 25 root 2, 25 into root 2, and this is 1.414. Now if you solve this 25 into 1.4, I am taking it approximate value, 2 4 to z to 10, 155 122 053. So this is approximately 35 meter per second. So this is I mean 35 kilometer per hour. Option D is the correct, isn't it? Next, Preeti reached the metro station and found that the escalator is not working. She walked up the stationary escalator in time t. Suppose this is the escalator, this is point A and this is point B. Agar Preeti reached the stationary, I mean she climbs up this stationary escalator in time t1. Let us suppose the length is given by L, isn't it? So speed of the Preeti must be v1 is equal to length by time taken is t, implies that you can write t1 is equal to L by v1. These two things can. On other days, if she remains stationary on the moving escalator, then the escalator takes up in time t. Now what happens? In this case, the escalator is not working, so she walks up the stairs like this one, isn't it? In the second day, in some other day, she just stands on the escalator and the escalator takes her up, isn't it? And the time taken by the escalator to take the Preeti from point A to point B is equal to t2. So the speed of escalator must be distance by t2. So here t2 is given by L by v2, isn't it? Now on some other days, what happens? She is in very hurry, so the time taken by her to walk up on the moving escalator will be. So she is in hurry, what happens? Escalator is moving, isn't it? And when she stands on the, I mean in the second case, she just stands on the escalator. But in the third case, what happens? Escalator is moving as well as Preeti also running on the moving escalator. So the velocity of the Preeti with reference to ground will be the sum of the two velocities, that is its own velocity with reference to escalator plus the velocity of the escalator, which also pushes her upwards, isn't it? So in the last case, when both are moving along the same direction, so the net velocity of the Preeti becomes v1 plus v2. Distance is again same, and let us suppose the time taken is t. So here t is L by v1 plus v2. So we have to find the time taken by her to walk upon the moving escalator, and this time is t. So this is L. Now what is v1 from here? L by t1. What is v2? L by t2. So if I take L as common, so here L 1 by t1 plus 1 by t2. So L gets cancelled, and this will be given by t is equal to, this is 1 by t2 plus t1 by t1 t2 is equal to t1 t2 by t1 plus t2. So this is the answer, dear students, isn't it? So t1 t2 by t1 plus t2. So this is the answer, that is option C. Next, a bus is moving with a speed of 10 meter per second on a straight road. A scooterist wants to overtake the bus in second. Let us suppose this is a scooter and here it is bus. Here it is bus. The speed of bus is 10 meter per second. If a bus is at a distance of 1 kilometer from the scooter, so this is 1 kilometer means 1000 meter. Now this scooter wants to overtake the bus within time interval 100 seconds. So what should be the speed of the scooter? So let us suppose the speed of the scooter is v. So this is the concept of relative velocity where both the objects are in motion. So the relative velocity of approach of the scooter with respect to bus is given by v minus speed of bus, that is 10. So this must be multiplied by time after which it wants to overtake the bus. So this is relative velocity, this is time, and this must be equal to product of speed into time must be equal to distance, that is 1000. So two zeros get cancelled. So here v is equal to 20 meter per second, isn't it? Next, two boys are standing at the ends A and B of a ground where AB is equal to A. Let us suppose this is the case. So here it is the boy A, here it is boy A, and here it is boy B. Now what happens? The boy at B starts running in direction perpendicular to AB. So this is the direction of motion of boy B, isn't it? It is moving perpendicular to AB, this line AB. Now the boy at A starts running simultaneously with velocity v and catches the other means the boy which is at the end A. It starts running. Why he is running? To catch the boy which starts his journey from B. So B, the boy from B is moving like this, the boy from A is moving like this. So let us suppose at some point t the both boys meet, isn't it? So the boy from B moves like this and the boy from A moves like this. Why I am taking this direction as this one? Because the word used here is catch. This is important word, isn't it? The word used here is catch, because the boy from A wants to catch the boy which is running from B, isn't it? It is like when you suppose you arrived a platform of a station and the train starts running and you have to catch the train. So you run diagonally to catch the train. Suppose this is the door, you reach here and this is the door of S7. So you have to get entry in this S7. Now the train is moving like this. So you have to catch this door. So how will you approach there? Diagonally, isn't it? Diagonally, this way. So the two, that is the door and the passenger, meets at this point. Similarly, let us suppose this is A, this is B, and this is the meeting point of the two boys. This distance, dear students, it is given as AB is equal to A. The speed of B, the speed of B, the boy at A starts running with velocity V. So boy at A, so speed of A is given as V here, and catches the other in time t. huh, catches the other in time t. And the velocity of the boy starts at running in direction perpendicular. This velocity is given as v, isn't it? So this distance is a. Now this distance is given by v1 multiplied by t. Why? Because v1 is the speed of boy which is running starting from b, and the time is t. Because after time t both the balls meet, so the journey time must be t. So the distance is given by v1 into t, and this distance is given by v into t, because he starts running and after time t he catches the another boy. So the distance just given by speed multiplied by time. So this is where t is equal to. So we need to find the value of t. So dear friends, just this becomes a right angle triangle because it is given this is perpendicular. So apply the Pythagoras theorem. So this will be vt square is equal to a square plus v1 into t square. We have to find the value of t. So this is v square t square is equal to a square plus v1 square t square. So this will be v square t square minus v1 square t square is equal to a square. So this is t square v square minus v1 square is equal to a square. On further solving, you will get t square is equal to a square by v square minus v1 square, or t is equal to root over a square by v square minus v1 square. You can take a square outside the root, so it will be left only a, isn't it? This can also be written as a by root over v square minus v1 square. But in the question it is given in square root format, so this must be the answer. Next, a vehicle travels half the distance with the speed v and the remaining distance with the speed 2v. Its average speed is, let us suppose the total distance is 2x, isn't it? Total distance is 2x. So half of the distance, that is x, it covers with the speed v. So let us suppose the time required for covering half the distance is distance by speed, that is x by v. Remaining half distance it covers with the speed 2v. So implies that the time taken to cover the remaining half distance is x by 2v, isn't it? Average speed. So average speed is given by total distance by total time, that is the total distance is 2x, total time is t1 plus t2. So this will be 2x by x by v plus x by 2v, x by v plus x by 2v. So this is x common. So this is 2 by 1 by v plus 1 by 2v, 1 by v plus 1 by 2v. And here also x, so this must be cancelled. So v average is equal to 2 by, this is 2 plus 1, taking LCM as 2v by 2v. So this will be 4v by 3. So this is the answer, 4v by 3, option A, isn't it? Next, a person traveling in a straight line moves with a constant velocity v1 for certain distance x and with a constant velocity v2 for next equal distance, isn't it? Suppose the person travels x meter with velocity v1 and the next x meter with velocity v2. This is given. The average velocity is given by in this way. So the total distance traveled by the person is 2x, isn't it? And this total distance traveled by the distance, let us suppose this is given by v average. So we have to find the expression equating this two. So from here we can say the time taken to cover this distance x with speed v is given by x by v1. From here we can say the time taken to cover the same distance x but with speed v2 is given by x by v2. So from here we get the time taken to cover the distance 2x with average speed, that is uniform constant average speed, is given as 2x by, this is v average, and this v average it is given as v, isn't it, in this question. Now dear students, as per the according to definition of average speed, this t must be equal to t1 plus t2. Because what is the concept of average speed? Suppose you are covering some distance with different speeds and you take 1 hour for covering that distance, but you have covered that distance with different speeds. So what is the concept of average speed? If you cover the same distance in same time interval, that is if you cover the same distance in the same 1 hour, by following a single speed. So that single speed is known as average speed. So whenever you talk about average speed, the time must be same. The time of journey must be same. Here also, the person traveling the entire journey with two different speeds, V1 and V2, and he takes the time T1 and T2. So total time it takes is T1 plus T2. So if I talk about average speed, so average speed is that speed with which if person moves uniformly, then it covers the same distance in same time. So it is covering the same distance 2x, so the time must be same. That is t must be equal to t1 plus t2. So 2x by v is equal to x by v1 plus x by v2. X. So this is 2 by v is equal to 1 by v1 plus 1 by v2. So option B. Next is a car covers the first half of the distance between two places at 40 km per hour. First half. Let us suppose x by 2, it covers this distance 40 km per hour. So time for this covering this distance is distance by speed, that is x by 80. Second half, other half x by 2 at 60 km per hour. So time for this is this distance by speed is x by 120. So this is in hour, this is in hour. So the average speed of the car is given by, so V average is total distance by total time. So x by 2, x by 2, so total distance will become x, and the time is t1 plus t2, that is x by 80 plus x by 120. So this is x by 80 plus x by 120. So taking common xx from above and I mean numerator as well as denominator, so this will be 120 plus 80 by 120 into 80. So this will be given by 120 into 80 by 200, cancel, and this is 96 by 2, that is equal to 48 meter. So I mean, sorry, not meter, it is kilometer per hour. Now we are finding average speed, dear students. So this is kilometer per hour because we are in kilometer per hour unit system. Next. So that's all for this lecture. Thank you. We will meet again by in the next lecture we will cover the motion plane, that is projectile uniform circulation. That's all. So till then, keep studying. Thank you. All the best.